All right, let's talk about Next.js. If you've worked with it, you know that caching system can feel like, well, pure magic. But then, one day, it doesn't. And when it breaks, it can be a real headache. So today, we're going to pull back that curtain. We're going to demystify all of it and give you the keys to the kingdom, turning that unpredictable magic into a tool you can control with total confidence.
Okay, so here's the plan. We'll start with a quick look at the bigger picture, the architect's view. Then we'll lay the foundation with rendering and this thing called the RSC payload. After that, we dive deep into the caches, first on the server, then on the client. And we'll wrap it all up by showing you how to take command of the whole system.
So let's zoom out for a second. In a world where AI is getting pretty good at churning out code, our value as developers is changing, right? It's becoming less about just writing the code and more about being the architect, about making those big, smart decisions that affect the entire application.
Yeah, it's about having that eagle's eye view so you can see the whole system at play and swoop in to fix problems before they even start. And to get that view, you really need to understand the why behind how Next.js works. That all boils down to two key pillars, rendering and caching. Master these and you've mastered the framework.
Okay, let's get our hands dirty. Before we can even touch caching, we have to get on the same page about how Next.js actually, well, builds a page. There are 4 main strategies, so let's run through them real quick.
First up, we've got static site generation, or SSG. The restaurant analogy here is perfect. It's like the kitchen preparing its most popular dishes before the dinner rush even starts. Everything is pre-built, ready to go. When a user asks for it, boom, it's served instantly. This is why it's incredibly fast for stuff that doesn't change much, like a blog post or a company's About Us page. Now, on the complete other side of the spectrum, you have server-side rendering, SSR. This is your a la carte menu. Nothing is made in advance. When a user places an order, makes a request, the chef, or server, cooks it up fresh from scratch every single time. It's amazing for highly personalized content, like your social media feed, but you pay a small price in speed because the server's working hard on every visit.
So you're probably thinking, can I get the speed of static with the freshness of server-side? And the answer is yes. That's exactly what incremental static regeneration, or ISR, is for. It's the brilliant middle ground. The restaurant keeps a batch of popular dishes ready, but every hour they remake them to ensure they're fresh. So users get that instant speed, but the content never gets too stale. Think of an e-commerce site showing product stock. Perfect for this. And last but not least, client-side rendering. CSR. This is like one of those meal kit delivery services. The server just sends you a box of ingredients, a nearly empty HTML page, and a big JavaScript file. Then you, or rather your browser, does all the cooking right there at the table. This is the powerhouse behind those super interactive web applications, like a complex dashboard where the page is constantly changing without needing to reload.
All right, this is where things get really cool with the newer versions of Next.js. It's all about splitting the work. You have server components, which are like the foundation of your house. They're built on the server, they're great for fetching data, and their code never even gets sent to the browser. Then you have client components. These are the interactive bits, the light switches, the faucets. Their code is sent to the browser, so you can actually click on things, manage state, and make the UI come alive.
So how does the server tell the browser what the UI should look like without sending a mountain of JavaScript? That's the magic of the RSC payload. Instead of sending the whole blueprint and a construction crew, the server sends a super compact set of instructions, this logbook. It tells the browser exactly what the server-rendered UI looks like. It's incredibly efficient and a huge part of what makes the app router so fast.
Okay, foundation is laid, we understand rendering, now we can finally start talking about caching. We're going to start on the server side, where a couple of clever caches are working behind the scenes to make sure we're not doing any more work than we absolutely have to.
Let me ask you a question. Picture this. You've got a page with a header, a sidebar, and a main content area. And let's say all 3 of those components need to fetch the current user's data. You write fetch user in each one. So how many times does your app actually hit the network to get that data? 3? 4? What do you think?
Nope, just 1. Not 4, not 3, just a single request. How? It's thanks to a really smart built-in feature called request memoization. It's basically React saying, hey, I see you're asking for the same thing multiple times in this one go. I'll just ask for it once and share the answer.
So the crucial thing to remember here is that this is a temporary in-memory cache. It only exists for the duration of a single render. But man, is it powerful. It means you don't have to worry about passing props down a huge component tree, a process we call prop drilling. You can just fetch the data right where you need it, even if that's in 10 different places, and React takes care of the deduplication for you. It's a huge win for clean code.
Okay, now let's talk about the data cache. This is a different beast altogether. While request memoization is temporary and lives in memory, the data cache is persistent. It lives on the server's file system. It doesn't just deduplicate requests within a single render, it saves the actual data from a fetch call so that it can be reused across different renders and even different users. This means you might not have to hit your database or that external API at all for the next person who visits.
All right, we've covered caching the building blocks, the data. Now let's talk about caching the finished product, the fully rendered pages themselves. And for this, there's a cache on the server and another one that lives right inside the user's browser.
And this is such a critical distinction. On the left, the full root cache is a server-side thing. It stores the complete HTML and RSC payload for your static pages. Its whole job is to make that first visit to a page absolutely blazing fast. Then, on the right, you have the router cache. This one is client-side, in the browser's memory. It cleverly holds on to the payloads of routes you've already been to, so when you click a link to go back, the navigation is literally instant. No loading spinner. It just feels like magic.
Okay, you've made it through the labyrinth, you understand all the different layers of caching. Now for the best part, taking control. Because all this caching is useless if you can't tell it when to update. Let's look at how you can become the master of this system.
You've basically got two main levers to pull. The first is time-based revalidation. This is the set it and forget it approach. You just tell Next.js, hey, this data is good for about 10 seconds, and it handles the rest. The other lever is on-demand revalidation. This is the big red button. You've just published a new blog post in your CMS, you hit publish, and it sends a signal to Next.js to immediately clear the old cache and fetch the new stuff. Super powerful.
So that's a lot to keep in your head, I know. But what if I told you there's a simple framework, a master key, that unlocks all of it? You don't need to memorize every detail. You just need to know which questions to ask. I call it the 3W3H framework. And here we have it, the whole system, all on one table. This is your cheat sheet. Let's just walk through it one last time. We have request memoization, which was all about deduplicating requests during a single render. Then there's the data cache, which stores the results of those requests on the server's file system to reduce database calls across all users. After that, the full route cache stores the final HTML on the server for a super fast initial load. And finally, the router cache lives in the user's browser, making navigation between pages feel instant. What is it? Where is it? Why does it exist? How long does it last? How do you refresh it? And how do you tell it to just not cache? Every answer is right here. This slide is worth bookmarking, for sure.
And just like that, you've gone from coder to architect. Seriously, what used to be this black box of framework magic is now just a set of tools. You know what they are, you know where they are, and most importantly, you know how to control them. You're not guessing anymore. You're building faster, more efficient applications with intention.
But of course, the journey never really ends. The ecosystem is always evolving. There's already new stuff on the horizon, like React's Use Cache hook, which promises even more fine-grained control over what you cache, even beyond just data fetching. But now you have the foundation, the mental model, to understand it all. So the real question isn't just, are you ready for what's next? It's, now that you're the architect, what are you going to build?